Good evening, Julie, salam everyone. So welcome you all for this today's webinar on the basic of astronomy, the night sky watching and space, uh, night sky watching and stargazing. And today we have with us Mr. Nayan, and we have started these few programs in the coming weeks and till the next month as a part of the National Space Day celebration on the eve of National Space Day celebration, and it's a proud moment for all of us that on the 23rd of August, India successfully landed on the south pole of the moon, and then Prime Minister of India has announced that 23rd of August will be celebrated as a National Space Day in India to commemorate this success. And as a precursor to this National Space Day, we have planned some activities. Then today's webinar, and tomorrow we have a night sky watch program at Jamnia School, and as well as satellite, and particularly the weather satellite tracking and direct satellite data and downloading demonstration by Dr. Stanzin Pasang. And the next Monday onwards, we are conducting 5 days science camp. As a part of that, we will be taking around 40 students to Ladakh Sky Reserve. There they will have a hands-on exposure to the deep space observations and being taking place at Hanle. And in the coming weeks, we will try to organize some more program. And 23rd of August, there will be some more programs that will announce. Will announce in the due course of time. Okay. And today, our speaker is Mr. Nayan. He is from Maharashtra, and he studied physics from the Manipal University, Jaipur, and postgraduate from University of Hyderabad. And his specialization he's more interested in the relativity, particle physics, and gravitational waves. And in the last 1 year, he has taught it in the schools about the astronomy. And presently, he is in Ladakh. And he is at HIAL, Himalayan Institute of Alternative Learning. That's a part of the SIGMOL. And presently he is HILS fellow at HIAL, and his interest is in preserving the skies and explore the astrotourism. And I'm very thankful to Mr. Nayan, and he has been helping us, Ladakh Science Foundation, as the Astro mentor. And we have been conducting some a night sky watch program, and we'll continue to do so more programs in the days to come. And welcome, Mr. Ryan, and I request you to go ahead with your presentation.
Okay, July everyone. I hope I'm audible. Yeah. So when we are talking about basics of astronomy, what I'm trying to cover is when you look up at the sky, what things can you see, and how do we make sense of it? How do we interact with the sky, and what things are up there? How do we explore them, right? As you can see, this is a spectacular image by Dorjang. He's an astronomer at Indian Institute of Astrophysics, leading things at Hanle, right? Which a lot of you are going to visit, I guess, in the coming week. So when you look up at the sky, there are many different objects that you can see from a very dark side, a very good eye. There are different type of objects, and they make you wonder. They uh, make you think like how we are connected to them, right? If you try to see, like, astronomy has been something that is not limited only to sciences. It been a part of arts. It has inspired many different art pieces. For example, this Starry Night, right, which is one of the famous paintings by Vincent van Gogh. So yeah, but when we talk about astronomy, we talk about what we can see, what is out there, what objects are there, what scientifically what objects to be study. Uh, so when you look up at the sky, for example, in Ladakh, you have really good skies, right? For example, the place I belong, the skies aren't that good. Okay. So when I look up at the sky here, Milky Way is just goes right above me. For example, today night, when you after Milky Way will be going right above your head. And if there was no moon, because it's the moonlight that actually outshines the glow of Milky Way, you can't see it. But on a night when the moon is absent, you can see Milky Way stretching over your head. There are a lot of stars. There are some objects that you can actually see with your naked eye. For example, this is the sky right above the place I live. So I live in Fiang, uh, where you have HIAL. And so this is what the sky looks right above me, right just uh, outside my home. So this is a long exposure image. And as you can see, as time passes, it's a time lapse. You can see the Milky Way moving. So it was taken right before sunrise. So you can see the dark sky changing into a bluish sky. That is due to sunlight. Yeah. And if you stack all the image, we get star trails. These are kind of images that you see out there uh, over the internet. Yeah. But what are the objects that are there up in sky and what we explore with things like telescopes, binoculars? So we have different kind of telescopes from small to large, and they all study these kind of objects. So, for example, when we talk about solar system, these are the objects that you uh, see up there in sky that you hear about when you talk about solar systems. For example, sun. So this is the image of sun just taken just today by Solar Dynamic Observatory, and you can see it's a part of the layer of the sun that you get the light from that you can see with your naked eye. And there are some dark spots you can see, those are the sunspots. So even the sun has a lot of features that you can study, that you can explore. And if you go further, there is moon. Sun and moon almost appears the same size when you look up in sky. And that's why we get things like eclipses. And yeah, if you go further, you have planets, right? Planetary objects. So this is Jupiter, this is Saturn. This is what you see. This is what these objects look like when you see through telescope. Okay. So these are not to scale, but these are what they look like. And also you can see the moons of these planets. You can see the four moons of planet Jupiter when you point your telescope to Jupiter. Similar with the Saturn, you can see some bright objects, some bright moons of it. For example, Titan, it's easily visible through a decent telescope. Now going beyond these objects, there are different objects in solar system that we can't see with naked eye. And, a very few asteroids that we can see with naked eye. For example, this is asteroid Vesta. So it won't appear this big in the telescope as well. So it is an image by a space telescope. But it is one of the brightest asteroids. You can see it with naked eye from a decent eye. Uh, yeah, then after asteroids, there are comets. For example, you might have heard of stories related to comets that past that have created curiosities among people. There are stories there are tales that people have associated with them. For example, there are passage of comets, people associate them with something, s- it as something lucky or something bad as well. Yeah. So, and there are many other objects in our solar system beyond these that you can see up in sky. So with naked eye, these objects that we have listed are easily visible. Yeah. So apart from the solar system objects, there are different stars that are visible, right? A sun is a star. So we orbit sun, and there are many objects objects in our solar system that orbit other stars. And these stars are of different colors. For example, I hope you can see my cursor. So if you see this, image, can anyone recognize which constellation is this, by the way? Anybody is familiar to this? Anyone,
Orion?
take a guess.
Is it
Yeah,
Orion?
that's Orion. Yeah, that is Orion. So a constellation that when you see it rising, you know it is winter time. When you see it rising up in sky just after sunset, you know winter is about to arrive. Yeah. So it's Orion, right? The constellation. So if you imagine this constellation, you can imagine some images associated with them. For example, it is imagined as a hunter with itself having a story related to it. Yeah. So in the end, you can see there is the star. Uh, it is reddish in color, and you can see it with naked eye. So the star is about to. We think that it might appear, it might die, and we might see a spectacular explosion in sky that will be as bright as moon, some phase of the moon, and you can see it for many days in sky. So yeah, can anyone guess which constellation it is, or which it's a part of a constellation, not a constellation, but can anyone take a guess? A Hindi name as well. Just take a guess.
Uh, Big Dipper.
Yeah, it's Big Dipper, right? Uh, you might have seen it in your books. So even now, it's whenever after sunset these days, you can see it right over your head or going to west. So yeah, it is Big Dipper. It's part of a bigger constellation, a polar bear, Ursa Major. And here as well, you can see many different stars with different colors, as well as you can see many multiple star system. For example, we had a sky observing session uh, 2 weeks back or a week back with kids from Ladakh Science Foundation, and we observed a double star that you can see it as a double star with naked eye, but it is a multiple star system. It's a sextuple star system. There are 6 stars which possibly are gravitationally bound. So these are kind of things that you can see apart from so the objects in solar system. If you go beyond, now we are talking about stars. Now these stars have their own life. They they are there is they born, they die, and we have stellar nurseries, for example, where these young stars are actually formed, and these are some kind of so these are type of gaseous structures that we call as nebula. Okay, so this is one of uh, the famous nebula that you can see actually with your naked eye. You can get a hint of it that there is something faint up there. So in Orion, if you see up here, so some you can see a faint patch that is actually the Orion Nebula that you're seeing here. So it's a image by Hubble telescope. So people who don't know, Hubble telescope was a prime telescope. Most of the images that you see on the internet were actually taken by Hubble, or the first good image that we got of many objects were actually from Hubble because that was the prime telescope. Uh, it's by NASA, ESA, and it has been for years and it's still there. So what you see here is actually the factory where the stars are formed. Now, there are objects like galaxies. For example, this is Andromeda. If you have heard of it, so it is one of the nearest galaxies and a bigger galaxy than our galaxy that where we live. So, so it is a big galaxy that, and you can see it with your naked eye if you go to a good sky. For example, when I got a chance to go to Hanley 2 months back, and it was right above the horizon, I could see it. It appears as a faint bright patch up in sky. So in sky, it actually bigger than moon. It's so yeah, these are kind of objects. Now we were talking about galaxies. We can also see our own galaxy up in sky. I told you about the Milky Way. The same Milky Way stretches right above us. So if you see in sky, it appears as a band. Can And here if we see, it appears something as a disk that we are seeing. So this is Andromeda. We are seeing it as a disk, somewhat slanted, right? It is somewhat slanted. Okay. And if you see up here, it appears as a band. Uh, Anybody has an explanation why it appears like that? So it is an all sky image. It is the whole sky you're seeing, and you're, you're seeing Milky Way going from one end to the other end, and it has been mapped. It has been somehow put over this rectangle, so you can see a greater part of the sky. Anyone has a guess why Milky Way appears as a band? Ah, okay. So, so these are kind of galaxies that we call as spiral galaxies. So they appear as a flat disk and they have arms. So imagine I have a flower in my hand and I twist the stem of the flower. Petals will somehow twist and they will turn a bit. So similarly, these galaxies appear somewhat like a twisted flower. They have these kind of arms on them. And we are actually living in one such arm of our Milky Way. If you can go far away from our Milky Way and try to take a picture, you will see uh, a disk like this. And we actually living in one such petal of this galaxy, one such arm of this galaxy. Uh, and when we are actually standing in this disk, we are actually around us. So if I make a hole over this disk and I sit in that and I look around, I will see a band around me. Okay. And if I look up, I won't see the galaxy because it's a flat disk. So we actually see a band surrounding us. And this is the Milky Way. So it appears somewhat white, milky white in color, and uh, it's a it's a band, it's a way that is up there in sky. So people named it Milky Way. So yeah, I hope that helped, that explained why Milky Way appears as a band, right? Uh, yeah. So this is an image actually from Hanle. There's the biggest telescope that is there. Uh, and yes, it is taken by the same person, Deutsche Anschauung. So if you go further, there are exotic objects in sky. Now, these were some objects that we can see with naked eye, or we can try with a decent telescope. But there are some objects that actually you can't see with the kind of telescopes or binoculars that you can buy. So these objects are actually some different kind of objects. For example, it's a crab pulsar. So when we talk about sun as a star, I told you every star has a life and it has a death as well. So there are different type of stars and they have their different life stories. So it depends on what type of star it is, it will have a different story. So some stars actually die as these exotic objects. So what happens when a star dies? It actually shrinks. So there's an explosion. It gives away uh, some of its mass that is actually so imagine, so it won't happen with sun because sun is a very low mass star. But if sun was a huge star, its mass was very large, it will have a different story. And what will happen? It will go an explosion that we call a supernova, and it actually gives away its outer layers explosion. So it is actually the debris from the star that is surrounding, that you are seeing here. And at the very center of this debris is actually a dead star, and it's what we call as a pulsar. Now, what happens in this explosion? That star actually shrinks to a very small size. It's as small as a city. So imagine a very big star. It's many times bigger than sun. It shrinks to a size as of a city, and it actually spins very fast. And when it spins, it's like a lighthouse. For example, if I take my mobile and you can see my flash. Now, if I turn my mobile, the flash will come at you and it will go away from you. It's like a lighthouse, right? So on a lighthouse is a light that actually keeps on rotating. Okay. So similarly, there are beams coming from the stars, these kind of stars, and they actually rotate. They come in your view and go away from you. So the star seems like it's blinking, and it's pulsating. So these are such kind of But you can actually see some more structures when you go beyond the kind of light that we get. These are X-rays. For example, you might have heard of X-rays in terms of taking scans of bones, but it's some different light that you can't see. Now, there are some other objects that might have heard of. You might have heard of it in movies, for example, black holes. So black holes are essentially black, so we can't see them, but there are some different type of phenomenon that happen around them that we can see them because of. So these images are actually taken by radio telescopes. Now, radio telescopes are different kind of light that you can't capture with the telescopes that you have at home. As in, you have to have a different type of telescope called as radio telescope. So if you have that, and for these kind of objects, like black holes, they can be very small or they are very far. And to see them, you need telescopes. For example, these images are taken by telescope as big as Earth. You need to make telescopes as big as Earth. Now, there is an interesting way how scientists try to make these kind of telescopes as big as Earth. We can discuss that further sometimes, uh, some sometime else. Uh, but I just want to convey you, there are objects that you can't see with your naked eye or the kind of light that our eyes are sensitive to. Now, there are different objects that you can explore if you have some different telescopes. For example, accretion disks. For example, around this black hole, you can see jets around objects. For example, this black hole in particular actually gives out some strong jets that you can see in some other images. And there are protostars. For example, there are stars that are still forming. If you go back to this image of Orion Nebula, so here are some stars that are still forming, that are in their nascent stage, young, that you can't see with visible light. You have to go in infrared light. So if you try to make a sense of light, so it starts from gamma rays and it goes to uh, visible that we can see, it goes to infrared, then it goes to microwaves, and then it goes to radio. So this is what we call as the spectrum of light. And you can see these different figures above. These are different type of telescopes, and these are their names. And these are sensitive in this particular color of light. You can see, so they can capture images. If you go to Hubble and you ask it, it can take in images in visible and infrared. So it can show you things that you can see with naked eye, and it can also show you things like protostars. Then if you go to Fermi, it can show you some very energetic events that you can't see with in light, that you can see in gamma rays. So we need different kind of telescopes to observe different kind of phenomena or different type of objects in sky. So the kind of telescopes that we actually use, that you might have seen around, if anybody has visited Hanoi. So a lot of people, if you stayed at farm stays, they have these kind of telescopes. Okay, so these are mostly optical telescopes or visible light telescopes, and you can see some visible objects with them. Okay, that we discussed earlier. So uh, we are planning to observe sky. How do we plan it? Okay, so what are the steps? How do we go if we want to explore this object in sky? What are the basic things that we require? So if you can see this image in front of you, that this is the sky from Fyang, Ladakh, and this is the sky from the place where I belong. It's Nagpur, Maharashtra. So, and it's actually in the same part of the year. It's taken in different year. It's taken in different year, but the same month of two different years, and all the sky position, the objects of the position of objects is kind of same. But you can't see the Milky Way as good as you can see here. You can see it's actually the similar part of the sky, but the Milky Way is somewhere hiding. I can actually see it faintly right here, but it's something is hiding it. So there is this glow that is actually hiding the sky, and is actually the light coming from the city lights, and it's what we call as light pollution. So if you're planning to observe sky, you need a place where actually the sky is really good. There are no lights around you. And what happens, the lights around when we use city lights, we actually leak some light up in sky, and it scatters in sky, as same as sunlight is coming to Earth and it scatters all over in the atmosphere, and atmosphere appears blue. But uh, same thing happens when the street lights actually leak sky in the atmosphere, scatters in the atmosphere. Okay, it scatters in the air above you, and it actually makes a blanket right above you that actually stops you from seeing the sky, right? So if you're planning, you need a good location. So you need good skies. So you need to find a place where you can actually see a good. So Ladakh, we have really good skies. For example, we planned an event in Gyamsa. So it's just a few minutes drive from Leh. But I had to plan same in around Nagpur. I had to do drive hours long, and still I want a sky as good as this. So yeah. Now, uh, there's actually an app that you can use to simulate sky right above you. So what you can use this for, so it works both on desktop as well as on mobile, any Android or iOS, whatever you're using, it works on that. So it simulates sky above you. Now, when you're planning to go to some site, you need to know where you're going. So you need to know the position. Now I tell you why do you need position. Uh, so you also need to plan which object will be where up in sky. So this app will actually help you. So I will try to share my screen by showing you this app. Uh, can you see this window? Can anyone confirm?
Yes, sir.
Yes, sir.
Okay, so there's the app that I just showed you, Stellarium. It's a free app that you can download. And it actually simulates the sky for you. So as you can see, it's in Leh. And here you can actually see the time that it is simulating the sky too. We try to hide this. Okay, it's showing the sky in real time, I guess. So it's 9:36, and it is what it looks right above Leh. And here below, you can see there are different kind of tools that you can use. So there are a lot of things that you can do in this simulation. Now, whenever you're uh, to go to a location and you're taking a telescope, you need to take it away from a polluted sky to dark side. That is the first thing. Now you also have to plan what time you want to observe the sky. For example, now moon is up, right? And it will be up till long. So you have to find at whatever particular time you're going to the site, the moon isn't there, or the phase of the moon is less enough that it's a crescent or something like that, so that you can actually have less glow up in sky as light is actually scattered in atmosphere. Same happens with moon. So it actually creates a same blanket, but that is not man-made. So uh, this, I'm trying to hide this. I'm not used to Zoom. Can anyone tell me how do I hide this bar that is coming?
Which bird, Naya?
Fine. I figured it. It's fine. The floating panel that comes, the meeting panel where you have the menu. So yeah, as you can see here, uh, so it simulates the sky. It shows you the direction where you are seeing. Now there is this thing that I told you, you need to know the location where you are going, because the sky appears different when you are at different locations. So as you can see, uh, here if I go at location. So now currently the location that is selected is Leh. But if I try to go to, let's say somewhere, please, let's drag it somewhere to the southern tip of India. So if you're going somewhere to the southern tip of India, I hope you can see that. I point to there, or let's select Kanyakumari. Okay, it's not there. Let's select Chennai. So if you select Chennai, you can see the sky has moved a bit. The time is same, but the sky has moved a bit. Because it happens because where you are standing on Earth actually decides what the sky will look like. For example, if you search, so there is a search window where you can actually search anything in this app. So if we search for Polestar, but I will tell you what is Polestar. Uh, it's somewhere here, yes. Okay. So it's what we call as Polaris. Okay. So it is called as Polestar for a reason. So I will try to tell you what's happening here. So this Polestar, if we try to change the location, it will actually shift its position. Okay. If I go from back to Leh, and you can see, for some reason it's not going. So let's do return to default location. Just focus on this Polestar. So if I do return to default location, it actually goes up. Okay, I hope you saw that. Now it's because it depends. I told you it depends where you stand on Earth will decide how the star will appear, how the sky will appear. And Polestar is actually a reference that we take, that we can take, because what happens is approximately the rotational axis of Earth, if we think this is Earth and it's the axis of Earth, it actually, and we extend it beyond, we can imagine actually it appears like it is passing through the Polestar. So it is going right above Earth through the Polestar. And if we actually speed up sky, whole sky appears to rotate around this star. So you can see this, right? It's visible. So it's day and night. You can simulate everything in this. So this pole star, so it tells you that uh, it you need to know the location to simulate the sky properly above you. So we are in Leh now, and let's go to the current time. And this will actually show you different stars that are up there. You can go to anything, you can select it, and it will show you the name. It will give you the parameters, the related information that you need. It's too much. We don't need this much information, but yeah, it's all up there. Now, when you're doing this, you can select any time. Now we selected the position. Now you can select any date when you're planning. For example, tomorrow we are planning for a moon observation, right? We are planning it at 9 p.m. So, and we are doing it in Leh, so our position is right. Now, let's say we are going to 21st, right? And we are planning it around 9 p.m. We're planning to start it at 9 p.m. So if we go there, we look here, moon is still rising. Yes, it is. If you select it, it tells you where it is in sky, right? So this altitude azimuth is somewhat used for location. So I don't want to confuse you with that, but you can just see what place you will see the moon in. I hope it's set to the right thing. Let's do it again. Yeah. So tomorrow, it will be almost a full moon, right? You can see somewhere here that, uh, so it's actually a full moon. It's almost full moon, and you will be able to see it. Okay, so how high it will be, which direction it will be, you can see it. up here. So this is simply how you can plan your observation, right? And as I told you, Milky Way is still up here. It's actually Milky Way that is passing from here. Okay, as you can see, I just removed the atmosphere, and you can see the Milky. So we actually eliminated the light that is coming from moon. So there is no atmosphere, nothing is scattering the light. So you can do these kind of tricks in this software. So Milky Way is passing right beside the moon, and you can see it here. So if I bring the atmosphere back again, you can see it somehow actually makes it difficult for us to see the Milky Way when moon is up. So yeah, this way simply you can plan any observation. Okay, you need to find the position, you need to select the time or date whenever you're going at that place, right? It's as simple as that. But now there is also an application for that you have for mobile as well. Now, if you have it in your mobile, you can actually point it to sky. As we know that mobiles have different sensors, there are accelerometers, there are gyroscopes. So this app actually uses them to. So if you point your mobile at this particular spot in sky, it will tell you what is right there. Okay. So there's a simple way to actually navigate in sky. Okay. So this mobile app you can actually use at the site itself, right? So you're seeing a star, you point your mobile at that, and you will know what object that is. Okay. So yes. So yeah, as I told you, this is a screenshot from the mobile app, right? So that was from the desktop that you saw. Now you can get something similar in the mobile app as well that you can use on site. Now, also, when you're planning to go out there, there are many different things that you will observe, not just objects in sky. There are things like satellites. For example, uh, there's an image. So what I did, I took many images and I combined them together. So everything that you are seeing is actually a trail of a star. So there's an image taken over many minutes and I combined all the images. So as you know, as Earth rotates, things move in sky. So when stars are moving, you can see if you stack those images together, if you overlap them one over other, this all images, the points will link together to form a trail in sky. And you can see these trails up here, but there are some trails that are actually not going in the same direction. You can see going one up here, one here, there are crisscross here. Now, these are actually trails from satellites. Now, what happens whenever a satellite is passing above you, it will actually reflect some light above its panels or some other parts of it, and it will reach you. And it appears as a bright object, a small star that is moving in sky. So it is something different from a shooting star. So you will see a star that is moving, it is changing its brightness because as the thing moves, the angle, it changes its angle and it changes the amount of light that is reaching you. So brightness will change. This happens. So that's why the satellite is bright here and it is faint here, things like that. So when do you see the satellites? Do you see them all night long? No, you don't see them all night long, but you see mostly after sunset or before sunrise. An hour after sunset or an hour before sunrise. So what happens, it makes a perfect alignment for sunlight to be reflected to you. Now same doesn't happen in the midnight or things like that. Okay. At other times, I mean. So these are some other objects that you see in sky. But when you go to a very good location, a very good site, these things you will see plenty of them. So when I visited Hanle, after sunset, it started with one satellite and then we just kept on counting. There were so many of them. And you might have heard of starlings. So they're spectacular to see. You can see many satellites passing at once. I guess they launched 23 or something, 21 or 23 satellites. So you can see such kind of uh, passages right above you, many satellites passing at once. But they can be bad for astronomy, yeah, because they're just like light pollution is a blanket that hides away the sky that is behind it. Similarly, these kind of satellites actually create noise up in sky for us to observe. So yeah. Now, when you look up at sky, beyond these objects, there are some many different phenomenon that you can see in sky. Okay. For example, this is something zodiacal light. So when you are at a good site, so that's it's an image that is taken some minutes after sunset. Now, what happens after sunset? It as happened with satellites, something similar happens with dust that is up there in solar system. Okay. So now this is actually the dust that is settled around in the solar system. Whenever you draw solar system or you make model of it, you actually do it in a plane, right? You make all those orbits in one plane. They lie in one plane, and actually in that plane, be along with these planets, with asteroids, there is some dust as well. And what this dust does, it actually reflects the light back at us. This sunlight goes in this dust, it scatters, and it is reflected to us. And this light is actually something you see it as a pillar up in sky after sunset. Okay, so this is one such phenomenon, and there are many such. For example, aurora, right? So at so when we talk about Earth, okay, now at higher altitudes, for higher latitudes, so at pole or region near pole, you can see these kind of phenomena. But recently you had a joint phenomena, not those are not aurora, but something similar or triggered by the radiation, the debris or the solar winds that we get from sun. Actually, that is what this is what leads to these kind of phenomena. And one such phenomena they also observed in Hanle, right? So these are some spectacular things that you see in sky. So there are plenty of such. When you look up at sky, there are many things that are there to surprise you. Okay. So yeah, keep looking up at sky. Right. So that's all I could actually manage for today. So but I would like to take any questions, and if you want to discuss any particular things in further, we can do that.
Yeah, thanks, Nan. It was very informative. And any others, you can unmute and ask questions.
Sir,
Same as well. So
so my name is Ayan Rahman.
okay, where are you
So my
from?
question is, I'm from Choklam, sir, Leh Ladakh.
Okay, okay.
Yes, sir.
Yeah,
My
yeah. Please go
question
ahead.
is, who discovered crab polar
Crab pulsar.
pulsar? Yes.
Okay, so it's an interesting story. The how crab pulsar was discovered. So we didn't know of these kind of objects. Uh, So there was an astronomer who was doing an internship, and they were not actually looking for these kind of objects, but there somehow they actually uh, saw this thing. What happened? So these were radio telescopes, and they were looking up in sky, and there was this astronomer. I will try to search her name. So she saw something in sky that actually repeated. So it came every day at same spot of the sky uh, after some particular periodic interval. So it was something and a signal that was coming up from sky, and we were seeing it every day. And It was actually a signal that was also going up and down as it was pulsating. So that is how it was discovered. Uh, and for- to answer your question, who discovered it, we can search it. Yeah, so it was Jocelyn Bell. Yeah.
Mm, okay, sir. Sir,
Uh,
my second question uh, is uh, is there crab pulsar revolution?
yeah, it revolves. As in, you mean does it revolve, or you want to ask something about revolution?
Yeah, yeah, yeah. Yes, sir. It is.
Yeah, it revolves. Actually, what
Yeah.
happens, so it's an interesting thing. What happens when you have something spinning, okay, and you
Yeah.
somehow shrink it. For example, the textbook example that they give is of those ballerinas. Okay, they take turns, right? They twist on the toe, and what happens when their hands when they bring them closer, they actually spin faster. Okay, so this happens because of what we call as conservation of angular momentum. So whenever there is a star, okay, and I told you that these pulsars are become as big as the city or as small as a city. So they're huge and they shrink. They actually are somehow compressed to that size, and they actually carry this big angular momentum. And when you compress them, they actually start to spin faster. And yes, you get high spin rates, and those crab pulsars are spinning. And the best a model that you can think of is of lighthouse, like beams coming from lighthouse, and as the lighthouse spins, that beam comes at you, it goes away from you, so it is pulsating, and we know for sure that is somehow spinning, it's revolving. Yes.
Yeah. How much it take time for one revolution, sir?
Okay, so I think it is 33 millisecond. Is it so we can search crab pulsar uh, revolution rate. So it does 30 revolution per second. So you can imagine an object as big as a city completing one revolution in 30 seconds, right? So
Thank you,
how
sir.
fast that is.
Okay, sir. Thank you, sir.
Yeah.
Priyanka, you have any question? You have raised hand.
Yes. You said that we can fixate on polar star. We can calibrate based on the
Yeah.
polar star, and then we can like look for any other object. My question is, what if the pole star is that day is not visible to us?
Yeah. Actually, I didn't mean to tell you that pole star is what you need to look at to explore or take it as a reference. Actually, just showed you that pole star moves when you change location, because
Okay.
it was easy to show with the pole star. Now, pole star, when it is not visible, it creates some different challenges. I will tell you what those are. But you can still explore sky even pole star is not there. Okay, now what we use pole star for is actually whenever we point telescopes. So what happens, I told you when Earth rotates, things move in sky, right? So we need to move our telescope as well. So there are some different type of telescopes. We mount those telescopes on some structures. We call them as mounts. And there are different kind of mounts. So there are equatorial mounts. So what happens in this equatorial mount, if you put your telescope, so it can move in two directions. And one direction, if you keep on moving it, it will actually keep the object in view. So if you add a motor to it, you can automate the telescope. Okay, and it will keep the thing in view. Now, to actually calibrate or to put these mounts in proper position, we need pole star. We can also do it some other way. There are different methods. But yeah, for such kind of observations, you need pole star. But in the example I gave, it was just to show you that it changes its position at different locations. Now, one more interesting thing I would like to add. Now, the angle the pole star makes from the ground, okay, it is same as your latitude. Okay, it is same as what your latitude is. So I
Mm,
guess latitude for Leh is 30 or 33. So pole star will make an angle between that. Yeah, it's like that.
Thank
Okay.
you. Thank you.
Mm. Uh, are
Any
there any
other?
questions in chat? So somebody asked, does that mean they emit light in one direction only? Zulekha Jabin, if they are here, they can expand the question further. So we talk about that.
Yes.
Yeah. Yes, please. What did you mean in terms of pulsars? You meant or what?
In terms of stars.
In terms of stars, do they emit light in only one direction? Is it?
Yeah, because you showed with your mobile phone flashlight that if the beam
Yes,
is
yes.
from you or it is away from you,
Yeah,
so and they twinkle.
yeah. So, yes, what happens now? These pulsars are very interesting type of objects. So I will share my screen so that I can show you what a pulsar looks like. Uh, so if you see here, there was so if you just search pulsar, okay, you get the motorbike. But if you search, if you see what happens, the physics around these objects is very different. It's exotic because it's, as I told you, it's very squeezed, so the gravity is high. Because things are squeezed very close to each other, forces, the electromagnetic forces behave differently, and somehow the radiation is actually coming out of stars in two beams pointing away from each other, and it's like a lighthouse. That's why the lighthouse analogy is given, because it fits well with this kind of picture. And when it rotates, it actually comes towards you and goes away from you. So there is this very good animation. Uh, okay. So if you see this, so what happens, the beam come towards you and it goes away from you. So if you are actually mapping the brightness, if we are taking a reading, like what is the amount of light that is reaching us, it will actually peak, it will go down, it will peak, it will go down. So it will be a periodic pattern. So it seems it's like that. I hope it answers. So that is how what we think pulsars are like. And just to give you a real uh, uh, something real to show you. So here is actually a small video of crab pulsar. It is slowed down, but you can see the star is pulsating, right? So it's because it is rotating, and these radiation beams are actually going away and towards you. Yes. I hope it
Okay,
answers.
so now I got it. Oh, yes, sir. Now I got it.
Yeah.
Thank you, sir.
Uh, Anything more? Sir, how can we see black hole if it is invisible? So Liaquat has asked this question. Uh, so as I mentioned when I was talking black hole, we can't actually see black holes uh, directly, as in principle, we shouldn't be able to see it because it is black. It takes away all the light. Uh, but what happens, there are many different things happening around a black hole. For example, the image of the black hole that we saw, you see a black hole between and some orange thing around it. It is actually the things around the black hole, the energetic events happening around a black hole that actually leads to emission of radiation. And when it is reaching us, it is forming that picture for us. So what happens whenever there is a black hole and things are falling into it? You might have heard that there are violent things happening around a black hole. So what happens? Stuff rotates around black hole, and because the gravity is high, there are some energetic events, and not all stuff can fall into the black hole all at once, because there is a limitation to it. So it gathers around the black hole, and when things gather around black hole, there is some energetic events happening. For example, when you rub your hand, it gets hot. Same happens with the stuff that is there. We call it as accretion disk, and it leads to radiation, and we can actually see that radiation, and we know. Now the other is, whenever things are around a black hole, a black hole, if it is small enough, if it is very small, and the star is orbiting it, the gravity is high, and you can actually see that, you can actually estimate if a star, you can see the star is revolving around something. You can't see this object, the black hole, but you can see the star is revolving very fast. You can estimate the mass of this object that is missing. It seems to revolve around, and you can tell it's a black hole. So these are some ways we know we have found some black holes. It's like that. Yeah. I'm not sure if Liaquat was here. Easier. Yes. Anything more? So I would like to add that because we are having a festival at HIAL, so I was very I didn't get time to prepare much because I wanted to add many things to it. But maybe we can discuss related to sky observation tomorrow at the session that we'll have. I just got an hour to put the slides up. Yeah.
Yeah, thank you, Nan.
Yeah.
In fact, I have given you very short notice. Maybe day before yesterday, I think, no? Just 2 days notice. You prepared this much. Thank you, and we look forward for your program tomorrow.
Yeah.
The students, those who are attending the science camp, they must come tomorrow, and tomorrow's session is open to all. Any students can come. It's a Jamia school in Ladakh. So we are in Mr. Nayan. He will be showing you the moon. We'll try to show the moon craters. We have 8-inch telescope. With the telescope, we'll do tomorrow moon watch program. And he was mentioning in his lecture that just 1 week back we conducted star gazing out sky watch program in Gamsa, that is in Leh, around some 5-6 kilometers in the Leh town. So it was fantastic. So a similar session will continue to organize. You all are welcome. It's free. And whatever the Science Foundation activities are, it's completely free. And there are like many organizations in Ladakh, they are charging around 2,000 for the 2 hours and night sky watch. Some are charging 3,000 for just for 2 hours, and we are conducting absolutely free. So you all should take advantage of this and try to learn as much as possible. And today's this lecture I'll be posting into the Science Foundation YouTube channel. You can go through it and look forward for a very interesting night sky watch tomorrow, particularly the moon watch. And thank you everyone. And I think we can now close the session. No? Now it's already 10:10. So thank you, Nan, and thanks. And we have some senior scientists from Shri Kumar sir. He is from Nuclear Power Corporation of India, and also Dr. Rao. Would you like to add something?
No, but yeah, this thing, try to go out, try to look around, check the sky. Yeah, a simple app that I showed you, it's a good reference. You can use it anytime, right? It's freely there. So yeah, try to look around. That's it. Try
Yeah.
looking up.
Okay, students. Thank you all for patiently listening to the interesting lecture, and looking forward for a very interesting moon watch tomorrow. Thank you, Nanji. Thank you, everyone. Good night.
Thank you. Good night.
Thank you. Thank you. Thank you.
Yes, sir.
Thank you. Thank you. Good night.